Okay, guys, awesome. So this is our next lesson here. This is, we'll call this, let's do it in blue. Lesson 3.2, explicit and recursive formulas. Formulas, okay? And our goal today, it's written on the board, but I'm going to write it down here as well. Our goal today is we will understand the difference between them, between explicit and recursive formulas. All right, cool. This is our major goal here. Okay, so what I want us to do is I want us to look at the warm-up that we did yesterday. Okay, let's look at the warm-up we did yesterday. And you remember it looked something like this. This was our start. It had one dot. I forget if it was 1 minute or 1 hour. I think it was 1 minute. At 1 minute, it looked like this. At 2 minutes, it looked like this, etc., right? You guys remember this? It was yesterday. Yesterday was a long time ago, but I think we remember this. And then we also built a chart for it. You know, we had time where we had 0, 1, 2, and then we had the generic t. We had the number of dots, which was what? 1, 5, 9, and then this became our formula, 4t plus 1. And then we also had our growth, where we noted that at step 1 we had our original amount plus 4. At 2 we had our original amount plus 2 4s. And then just generically we had our original amount plus 4 times the number of t's we had. Okay, you guys remember this? This is just kind of summarizing what we did yesterday. So what I want to do here is I want to just kind of talk about what we did. When we built all of this, we ended up with this little gem right here. We knew that our number of dots, which I'm going to say is d, equaled 4t plus 1. We saw that the number of dots equals 4 times whatever time it is plus that original dot plus 1. Okay? When we created this formula, what I didn't tell you at the time is there's a name for this type of formula. And we call this an explicit formula. Explicit. Now, explicit means it tells you everything. That's what explicit means. That's why, we talk about like explicit lyrics for music. It's because they don't censor themselves. They say all the words, whether or not you should hear them or not. Well, similarly, an explicit formula tells us all the information we need to know. It says everything. We know the growth, right? We know that the 4 is our growth. And we know that the 1 is our starting amount. But what I want us to think about is, in addition to explicit, our brains are doing another complicated feature. Our brains are also thinking recursively. Recursively. So recursive. What does recursive mean? When you hear the word recursive, what do you think of? Cursive. And what does that sound like? What's cursive? Way of writing, right? So recursive, if cursive sounds like writing, what do you think recursive is? Rewriting. Okay, perfect. So a recursive formula is a kind of a way of rewriting the step before. Because look at what happens here. When we go from start to 1 minute, what did I do? I added 4, right? And when I went from 1 minute to 2 minute, what did I do? I added 4. And we know that for the next step, I'm going to add 4. So another way of thinking about this pattern, and the way that we say it out loud, is each step, we would say each step is the previous step. And then what do we do to the previous step? We add 4 to it. Does that make sense? That's just kind of like a verbal way of saying it. Each step is the previous step plus 4. Okay? Now, here's the cool thing. There is a way we can do this mathematically. There's a way we can talk about this in math. I'm going to keep using the green pen. You guys remember when we were talking about function notation, right? You know, so what we would say here to rewrite this as a function would be f of t equals 4t plus 1. Where all we're doing is we're changing our y, we're changing our output to an f of x, or in this case f of t, because that's our variable. So when I look at my chart here, my 0, my 1, my 2, my t, I can view this, if 0, 1, 2, if that's my x variable, if that's my input, if that's my independent variable, if that's what goes into the function machine. You guys remember the function machine? It's like a meat grinder. You know, we put x's in, we get f of x's out. I can view this as f of 0. I can view this as f of 1. I can view this as f of 2. And I can view this as f of t. Does that kind of make sense? f of 0 is 1. The function of 1 is 5. The function when we plug in 2 is 9. F of t equals 4t plus 1. You guys following me? This is kind of like just another way of writing it. Instead of writing d as a y value, I'm writing f of t instead. So when we're talking about recursive functions, you know, let's look at f of 2, for example. F of 2 is 9 in our example here. F of 2 is 9. But if I just think about it, let's say I didn't know what f of 2 was. Let's say I didn't know what this formula was, but I knew what f of 1 is. Well, I know that f of 2 is going to be whatever f of 1 is if I just add 4 to it, right? F of 2 is f of 1 plus 4. Does that make sense? Each step is the previous step, f of 1 plus 4. That's all that that's saying. This step is the step before it plus whatever our growth is, plus 4. So we know that f of 3 is going to be whatever f of 2 is plus 4. And so we know f of 2 is 9. If I add 4, I know that f of 3 is actually going to be 13. Does that make sense? It's just another way of saying all the things that we've already been saying. But here's the thing. We can extrapolate that into a general statement. So I could say that f of t is going to equal f of t minus 1 plus 4. And so what am I saying there? What does that f of t minus 1 mean? What do I mean when I write f of t minus 1? It's not necessarily the start with the 1. That's not why I have that minus 1 there. That's a good guess, though. Essen?
It's talking about the step right before it.
Absolutely. It's talking about the step right before it. So step 2, if t were 2, is step 1, because 2 minus 1 is 1, plus 4. Step 5 is step 4 plus 4. Step 100 is step 99 plus 4. Does that make sense? So f of t minus 1 is relative to the step before it. And that's why we call it recursive. We call it recursive because you're rewriting the previous step, and then you're doing whatever your growth is. This is the previous step. So let's look at the example we did today for our warm-up. Does anybody need this up here for a little bit longer? We good? Okay, if you need it, you can look at it again. I have it all ready to go. But let's look at the problem that we did earlier today. It looks something like this. We had this, 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 and this was our start. We then grew it by 1, grew it by 1, grew it by 1, so we grew it by 3 overall. And then we grew it by another 1, another 1, another 1. So we grew it by 3 overall. So for this, we came up with the explicit formula together. The explicit formula was the number of dots equals the rate, which is 3, times our time, plus our starting amount, which was 6, right? We were able to come up with this together. How would we write this as a recursive function? How would we write this as a recursive function? So each step is, what do I write here? F of t minus 1, it's the step before it. And then what do we do to the step before it to make that next step? Connor? Do we add 6 each step?
3.
We add 3 each step, right? This is the new one, new, new. This is the new one, new, new. So each step is the step before it plus 3. And that's it. So that is the difference between explicit and recursive. They both are describing the exact same thing. They're both describing this pattern, assuming it goes on for infinity. But the way that we write it is very differently. Any questions? You guys ready to try something else? Fist of 5, how do we feel? 5, super clear. Fist, like, no way. Anything less than that, like, Victor, this is a weird wrinkle. I'm not sure I totally get it. Okay, cool. There's a lot of confidence here. So let's actually put it to the test. I'm going to stop the recording.